Good day, everyone. I'm Arvin Enriquez, your subject teacher. With this video lesson, we're going to discuss evaluating functions under your General Mathematics from Quarter 1, Module 2. Our lesson objectives. At the end of this video lesson, you are expected to first, recall the process of substitution. Second, identify the various types of function. And last lesson objective is to evaluate functions. Do you still remember? We have learned that in algebraic expression, letters can stand for numbers. And to find the value of the expression, there are two things that you have to do. First, replace each letter in the expression with the assigned value. For example, if there is a given expression and you're asked to find the value of this expression with a given value of variable, we're going to replace this variable with a given value for this variable. Second, perform the operations in the expression using the correct order of operations. Right after substituting the given value to a variable, we should follow and thus. So don't forget to use the correct order of operations. First, do any operations involving exponent. Then, do multiplication. The next thing is division. And finally, do addition and subtraction. In a simple word, right after substituting a given value, you need to follow your MDAS. Let us now recall the concept of substitution. So with a given expression here, we're asked to find their values using x is equal to 3 or by simply using 3 as the value of x variables in each of the given expressions. Again, our task is to find their value using x is equal to 3. Applying the concept of substitution, no, and dealing with this first expression, which is x minus 9, we just simply replace x variable by 3, or we just simply substitute 3 as a value of x variable in our first equation. That's why it's 3 here. Then, upon simplifying, your 3 minus 9, so since the absolute value of 9 is greater than the absolute value of 3, so we need to follow the sign of 9, which is negative. That's why 3 minus 9 is equal to negative 6. So that will be the value of your first expression when your x is equal to 3. How about our second expression, which is 3x plus 7? The same process. We just simply replace x by simply using your value, which is equal to 3. That's why it's 3 multiplied by 3 here plus 7. So if we simplify your 3 multiplied by 3, it's 9 plus 7. So they are both positive numbers. So we just simply add their values. So 9 plus 7 is equal to positive 16. So this will be the value of your second expression. Now, going to your third expression, so there is an involvement of an exponent which is equal to 2. So we just simply replace x by 3, or we just simply substitute 3 as the value of your x variable in the third expression. It's the same process with your first and second expressions. Now, we just simply substitute 3 as the value of your x. That's why it's 3 squared we copy your 4, then we replace x as by 3 minus 10. Now, 3 squared is equal to your 3 multiplied by 3. In a simple word, if 3 multiplied by 3, so that will be equal to 9. So if we multiply 4 by 3, that will be equal to 12. So we copy your negative 10. So 9 plus 12, or 9 and 12 are both positive numbers, so we can add their values. So 9 minus 12 is equal to 21. Next, minus 10, so meaning to say 21 minus 10 is equal to positive 11. So this will be the value of your third expression. Now, going to your fourth expression, it's the same process that we're going to substitute 3 as a value of your x variable in the given expression. Now, for your fourth expression, which is 2x squared minus 6x plus 26, again, we just simply substitute 3 as a value for x variable in this given expression, or we just simply replace the x variable in this given expression by 3. So we copy your numerical coefficient under your x squared. So we replace x by 3, so that's why it's 3 squared. Minus 6, so we copy your numerical coefficient from your second term. Then we replace x by 3. That's why it's 6 minus 3 plus 26. Now, 3 squared is equal to 9. Multiply by 2, that's why it's 18. So 6 multiplied by 3, then 6 is a negative number and 3 is a positive number. Negative multiplied by a positive number, that will be a negative resulting value. So negative 6 multiplied by 3, it's negative 18. So we copy your positive 26. So since your first and second term, no, there is a resulting values here, which is 18 and negative 18. So we can easily cancel out here. That's why it is equal to 0. So our resulting value for this expression now is equal to positive 6. Because we just simply cancel your negative and positive 18. Because if we subtract 18 by 18, then that will be equal to 0. So 0 plus 26 is equal to positive 26. So 26 is the value of your fourth expression. Now, going to your fifth expression, which is 3x cubed. Same process. We just simply substitute 3 as a value of your x variable in the given expression. So we replace x by 3. So that will be 3 cubed here. So we copy your negative 6. So negative 3, 3 cubed is equal to 3 multiplied by 3 multiplied by 3. So that will be 3 times 3, 9 times 3, it's 27. That's why it's 27. So we copy your numerical coefficient from your first term, which is 3, minus 6, which is your second term. So we simply multiply 3 by 27, so that will be equal to 81. So we copy your negative 6. So 81 minus 6, since the absolute value of 81 is greater than the absolute value of negative 6, so we copy the sign of the greater value of a term, no, which is 81. So 81 minus 6 is equal to positive 75. Therefore, the value of your fifth expression, if x is equal to positive 3, is equal to 75. Let us now deal with your types of functions. So here there is a table here. So I have your types of function in your first column, its description in your second column, and example of these functions, no, under your third column. So first type of function is that your constant function. So your constant function follows this format, wherein your fx is equal to b, where your b is a constant. Mean to say your b as a term, no? So there is no involvement of your variable x in your b. So we just simply use y to represent your function f of x. Or we can replace f of x by simply using your y. Here, your b is just a number. So meaning to say, when we say your b is a constant, there is no involvement of a variable x, wherein at some point we're going to put some values on it. So when we say a constant, a single value that does not change because there is no variable attached to it. Because your b here, is just a constant. Your b here is just a number without any variable attached to it. So that will be your constant function. Now, the next type of function is your identity function. So the identity function is a function which returns the same value. So you need to take note of this, which was used as its argument. So in other words, the identity function is the function f of x is equal to x for all values of x. Meaning to say, so whatever value that you're going to put here as a variable x in your function, that will be the resulting value of the entire function. So if we put x as a value of your variable x, in the given function, so the resulting value of this function must be equal to the value that we've put as a value of your variable x in the given function. So that will be your identity function. For your example, if we put 2 as the value of your x in the given function, for example, then this f, or the function with respect to 2, now is equal to the same value that we've put as a value of your x variable in the given function. Next is your polynomial function. So a polynomial function is defined by, so there is a given pattern here wherein we can use it for us to identify if the given function is a polynomial function or not. So where n is a non-negative integer, your a raised to o, a raised to 1, a raised to 2, up to the n, wherein the element of all real numbers. So it is a positive, positive real numbers, which start from 0 to a positive infinity. So first example of your polynomial function is your linear function. So the polynomial function which degree 1. So I mean to say the highest exponent that you can see, you will see, or you can see in this type of function is equal to 1. So that will be the high exponent that you will see on this function. Meaning to say, from the word linear function, it is a function that represents a line. That's why going back to your geometry, so we just simply use this y is equal to mx plus b, where your m is your slope and your b is your y-intercept. So if we give an example of this will be your y is equal to 2x plus 5, your 2 is your slope, and your 5 positive 5 is your y-intercept. If your m is a positive value, then your slope rises, your line rises from left to right. If your m is a negative value, then your line falls from left to right. So that will be the orientation, So by just simply looking at the given linear function or an equation of a line, by simply assessing what will be the value of the given slope. So if that is a positive, there is a given flow of a line. So there is a given direction. If that is negative, still there's a given direction for that. So by just simply assessing or and looking at the equation, we can identify what will be the direction once we graph the line or the equation that represents a line. So one example of your polynomial function is your quadratic function. So if the degree of the polynomial function is 2, then it is a quadratic function. Meaning, say the high exponent that you can see or you will see, in this function is 2. That's why in your leading term here, the exponent is 2. So where a is not equal to 0 and a, b, and c are constant and x is a variable. Now, using this general form of this quadratic function, no, where your a is your numerical coefficient under your x square, it should be not equal to 0. B and C can be equal to 0, but A should not be equal to 0. So as long that there is an x squared or a term that has an exponent of 2, even if this 2x or plus 5 is no longer visible on this function, it's fine. Even if y is equal to 3x square, as long that there is a term that has a variable and exponent of 2, this uh, equation is considered as a quadratic function, wherein your leading term has an exponent of 2. For the next example of your polynomial function is your cubic function. A cubic polynomial function is a polynomial of degree 3 and can be denoted by this general form, where a is not equal to 0, a, b, c, and d are constant, and x is a variable. Meaning say, as you can see in this example, your leading term is 5x cubed. The exponent of your leading term is 3. A must be not equal to 0, but B, C, and D can be equal to 0. But again, as long that this leading term is visible, and this term are not visible, it's fine. As long that there is a term and there is a variable attached to it with an exponent of 3, that equation is considered as a cubic function. For the next, the power function. So a power function is a function in the form, so we need to follow this one. So your y is equal to ax raised to b, where b is a real constant number. So meaning to say in your exponent b, there is no involvement of your variable x. When we say constant, a real constant number, this will be a number, without any variable attached to it. F of x can be replaced by using your y. So we can rewrite this one as y is equal to 8x raised to 5. And we need to consider this general form here. So many reference functions, such as linear functions and quadratic functions, are in fact power functions. Yes, it is, because there is an involvement of exponent, and their exponent is a real constant number. So here, your y is equal to ax raised to b, where your b, again, is a constant number. So meaning to say that there is no involvement of your variable in your exponent. So here your y is equal to 8 multiplied by x raised to 5 is a good example of a power function. Now, then your next type of function is your rational function. A rational function is any function which can be represented by a rational fraction. So this will be your rational fractions, in which numerator p of x and denominator q of x are polynomial function of x, where q of x is not equal to 0. Because if your denominator is equal to 0, it makes your fraction uh, undefined, no? That's why we really need to make sure, no, first thing to do is to check, no, if our numerator and denominator are polynomials. If we satisfy this first condition that both your numerator and denominator are polynomial here, then there is a possibility that the given function represents a rational function. But again, you really need to make sure our second condition, we need to satisfy your second conditions wherein your q of x is not equal to 0. Because if your denominator in a given fraction is equal to 0, then your fraction is undefined. So we really need to make sure that your q of x or your denominator or your polynomial under your denominator is not equal to 0. So if we satisfy the two conditions wherein your p of your numerator and your denominator are both polynomials, then your q of x or your denominator is not equal to 0, then the given function is a rational function. So our next type of function is your exponential function. So these are functions of the form y is equal to ab raised to x, where x is an exponent and a and b are constant, meaning to say that your a and b are numbers. Note that only b is raised to the power x. So the exponent x will be the exponent of your b in the given function, not to both a and b. So if the base b is greater than 1, then the result is exponential growth. So you need to check if b is greater than 1, then the result is exponential growth. So y is equal to 2 raised to x is the best example of your exponential functions, wherein your base is a number, then your exponent is a variable x. Next type is your logarithmic functions. Logarithmic functions are the inverse of exponential function. That's why there is a given conversion of exponential to logarithmic function or logarithmic function to exponential function. And any exponential function can be expressed in logarithmic form. Logarithms are very useful in permitting us to work with very large numbers while manipulating numbers of a much more manageable size. It is written in the form of y is equal to log base 7 of 49. This will be a good example of this one, wherein your x is greater than 0. So supposed to be this 49 here, this part of this function must be greater than 0, wherein your b or your base here is greater than 0 also, and your b is not equal to 1. Meaning to say, this b here as your base b, no, is greater than 0 and not equal to 1. It can be 2 up to a positive infinity, but not equal to 1 and less than 1. it should be greater than 0 and not equal to 1. So it can be 2 up to the positive infinity. So we really need to make sure that we satisfy these given conditions no, before we conclude that the given function is a logarithmic function. First, we follow a pattern of y is equal to log base b of x, wherein your x is greater than 0 and your b is greater than 0 and your b is not equal to 1. So we need to satisfy these three conditions being given here. Now for the absolute value of a function, the absolute value of any number c is represented in the form of c, or the absolute value of c. If any function f r approaches your real number r, is defined by f of x is the absolute value of x. It is known as absolute value function for each non-negative value of x, f of x is equal to x, and for each negative value of x, f of x is equal to negative x. So this will be a negative value of f of x and a positive value of f of x. For example, no, if your f of x, if x is greater than or equal to 0, if negative x, if x is less than 0. So we really need to go no with this pattern. Like in this one, y is equal to x minus 4. It's the same process, no? So whatever the value that we're going to put as a value of x here, we subtract by 4, and whatever the value it is. For example, 1 minus 4, it's negative 3. So the absolute value of negative 3, it's positive 3 plus 2 is equal to 5. So that will be the value of your absolute value function. So we're just simply getting the value of the absolute value of a given term. Next thing is the greatest integer function. If a function of f where r approaches your real number r is defined by f of x is equal to x, where x is the element of the bigger x, it round off no, to the real number, to the integer less than. So we need to take note, integer less than the number. So if we apply this one, so for example, if this is 2.4, what will be the real numbers, no? If we round up this one to the real number, which is less than the number, so that will be equal to 2. So if we round up this one, so we really need to take note of this, the integer less than the number. So 2 is less than 2.4. So suppose the given interval is in the form of k and k plus 1, the value of the greatest integer function is k, which is an integer. So where this absolute double absolute value of x is the greatest integer function. So you need to consider those things. And there's a given pattern, no? So what we really need to do is to look for the pattern available for us before we conclude and before we decide that the given function is the function like exponential, rational, logarithmic, absolute value, greatest integer function, linear, quadratic, no, polynomial functions, and whatsoever. So there's a lot of given conditions or patterns that we really need to follow for us to conclude and to give no the best description of a given functions. Let's go now with evaluating function. So evaluating function is the process of determining the value of the function at the number assigned to a given variable. So we're just simply substituting a given value to a variable for us to find or for us to evaluate a function. Just like in evaluating algebraic expressions, to evaluate function, you just need to replace each letter in the expression with the assigned value and perform the operations in the expression using the correct order of operation. So we just need to replace a variable, no, by a given values for this variable, and then we need to perform the operations. We really need to go with the operation for the term with exponent. Then we need to follow your m dash, your multiplication first, your division, and followed by your addition and or subtraction. So for the first example, given f of x is equal to 2x minus 4, find the value of the function if x is equal to 3. Now, there are two things that we need to do. We just simply substitute the given value to the variables in your given function, then follow the operations. So, we substitute 3 to your function, which is f of 3 now, is equal to 2 multiplied by 3, because we replace x by 3, or by just simply substituting, no, 3 as a value of your variable x here in your first term. So minus 4. So 2 multiplied by 3, it's 6. Minus 4, it's positive 2. So meaning to say your f of 3 now, or a function with respect to 3 where your x is equal to 3, is equal to positive 2. Then the answer now must be equal to a positive 2 also. So for example number 2, so given this g of x is equal to x squared plus 7, and there is a given find the function of g of negative 3. So we just simply substitute this negative 3 to your function variable in your given function g of x. So this will be now g of negative 3 is equal to 3. We copy your numerical coefficient from your first term, which is 3x squared. Then we replace x by negative 3. That's why it's negative 3 here, raised to 2 plus 7. So upon simplifying, no, negative 3 square is equal to negative 3 multiplied by negative 3. That's why it's positive 9. So 3 multiplied by 9, it's equal to 7. So we copy our constant, 7 here. So 27 plus 27 is equal to positive 34. So your g of negative 3 is equal to positive 34. Now, our final answer now is positive 34. For example 3, so given your function phi of x is equal to 3x squared plus 5x minus 2, whereas to find the value of your p of o and your phi of negative 1. So your solution, your phi of o now, so we just simply substitute 0 as a your variable x in your given function. So that will be your phi of o now is equal to 3 multiplied by 0. So replace x variable in your first term by simply using your 0 as a value of your variable x. Same thing with your second variable here. So we replace x by 0. So that will be 3 0 squared. So 0 raised to 2 is 0, no? That's why it's 0 here. So pi multiplied by 0, it's 0. We copy our constant here. So 3 multiplied by 0, it's 0. Then we copy your 0 here. Then we copy your negative 2 as your constant. Therefore, your piece of omo now is equal to negative 2. Now, what will be the value of p of negative 1? So there's an error here, no? So this will be p of negative 1. So your phi of negative 1 is equal to 3 multiplied by negative 1. So we replace now, no? We replace now your x variable using your negative 1. So negative 1 squared is positive 1. Then 5 multiplied by negative 1 here is equal to negative 5. We copy your negative 2 as a constant. So 3 multiplied by 1 is positive 3. We copy negative 5 and we copy your negative 2 here. So 3 minus negative 7, since the absolute value of 7 is greater than with the absolute value of 3. So we really need to follow the sign of 7, which is negative. That's why your piece of negative 1 is equal to negative 4. So this will be your final answer. For phi of O is equal to negative 2 and phi of negative 1 is equal to negative 4. So negative 2 and negative 4, these are our final answers for this example number 3. So for example number 4 here, so there's a given function here, f of x is equal to 5x plus 1. So we're asked to find the value of f of h plus 1. So meaning to say, this function here, no, is h plus 1. So there's a given expression, no, here, which is h plus 1, that we're going to substitute as a value of your x in your given function. So we replace all your x variable in the given function by simply using your h plus 1. So that's why it's 5 multiplied by h plus 1 here. We copy your constant here. Now we simply distribute this 5 to h and 5 to 1. That's why it's 5h and positive 5. So we copy your positive 1 here. So we copy your 5h, then we add this 5 and positive 1. That's why it's equal to positive 6. So there is no reason for us to simplify further this 5h plus 6. So your 5h plus 6 is your final answer for this example number 4. So because there is no given value for h. So if there's a given value for h, then you need to move forward in solving for the value of that function, no, with respect to the given value of h plus 1. But here there's no given value of h, then this will be the simplified, no, the most simplified term uh, for this final answer, no, which is 5h plus 6. So there is no such thing that we can simplify uh, more this uh, final answer, which is 5h plus 6. So for example number 5, so there's a given function here, which is g of x is equal to square root of 3x minus 2. So find your g of 9. So we just simply substitute 9 as a value of your variable x in the given function. That's why it's g of 9 is equal now to square root of 3 multiplied by 9. So we just simply replace this x by simply using 9 as a value of this variable. So that will be square root of 3 multiplied by 9 minus 2. So if we simplify this 3 multiplied by 9, it's 27 minus 2. So 27 minus 2, it's equal to positive 25. So since 25 is a perfect square, so once we take a square root of this 25, so that will be equal to 5. Now your g of 9 now is equal to positive 5. So this will be your final answer for example number 5. So for example number 6, same process, no? So there is a given function here which is h of x is equal to 4x plus 8 over 2x minus 4 here. And we're asked to find the value of a function if x is equal to negative 5. So we just simply use this negative 5 as the value of all your x variables under your h of x function. So we just simply replace those x variables using this negative 5. So we substitute this negative 5 to your variable x in your h of x. That's why it's h of negative 5. So we copy the numerical coefficient 4 here. Then we substitute negative 5 as a value of your x variable. That's why it's 4 multiplied by negative 5 plus 8 over 2 minus 5, because in our original, or in a given in the given function, which is h of x, your denominator is equal to 2x minus 4. That's why we really need to substitute negative 5 to x. That's why it's 2 multiplied by negative 5 minus 4. So if we simplify this one, 4 multiplied by negative 5, it's negative 20. We copy your 8 there. Then 2 multiplied by negative 5, it's negative 10 minus 4. So negative 8 minus 8, they are both negative, so we just simply add uh, we just simply add them, no? So negative 20 plus 8 now is equal to negative 12. So we follow uh, the number which has a higher value of its absolute value. Since the absolute value of negative 20 is 20, so we follow the sign of this 20. So that's a negative value. So negative 20 plus 8 is negative 12. So negative 10 minus 4. So we just simply add these two numbers because they are both negative numbers. That's why it's negative 14. So it's negative 14 and negative 4 are both negative numbers. So negative divided by a negative number is equal to a positive resulting value. So since 12 and 14 are divisible by 2, that's why if we divide 12 by 2, it's 6, and 14 by 2, it's 7. So our final answer for this example is 6 over 7, or simply your h of negative 5 is equal to positive 6 over 7. So for example 7, same thing, that there's a given function here which is f of x is equal to 2 raised to x if x is equal to 3 over 2. So your square root sign represents an exponent of 1/2. So if there's a given square root of x, so that will be equal to x raised to 1/2. So your square root sign here will represent an exponent of 1/2. If we apply this 3 over 2 as your exponent here, and to replace your exponent x, no, in your f of x is equal to 2 raised to x, so we can come up with this idea that your 2 raised to 3 over 2 is equal to square root of 2 raised to 3 by just simply following this pattern. So now your f of 3 over 2 is equal to square root of 8, because 2 raised to 3 is equal to 2 multiplied by 2 multiplied by 2. So that will be 2 multiplied by 2, it's 4 multiplied by 2, it's 8. So square root of 8 is equal to now, so we just simply get the factor of 8, which is 4 and 2. Since 4 now is a perfect square, so we can take the square root of this positive 4 and we can simplify. So square root of 2 now, since 4 is a perfect square, so we can take the square root of 4. That's why it's positive 2 here. Then multiply by square root of 2, because we cannot move, or we cannot calculate, no? Or calculate, no? We just simply simplify this function without using a calculator. So we're just looking for uh, the the most simplified form of our final answer. So if we're asked to compute, so we just simply use a calculator for us to get the value of this 2 square root of 2, which is somehow a number with decimal, no? or decimals. Now, your function f of 3 over 2 now is equal to 2 square root of 2. This will be your final answer for this example number 7. So for example 8, no, we're asked to evaluate the function h of x is equal to the greatest integer function of x, which is this symbol, plus 2, where f of x is the greatest integer function given to x is equal to 2.4. Now, we just simply substitute negative 4 to the variable x in the given function. Now, for us to simplify this one, your h of 2.4 is equal to the greatest integer function of 2.4 plus 2. With our conditions a while ago, with our greatest integer function, we just simply round up this one less than to the given value of your variable x, which is 2.4. If we round up this one to the which is less than to this value to make it a whole number, so that will be equal to positive 2. So we copy your positive 2 here. So your h of 2.4 now is equal to 2 plus 2, or simply equal to positive 4. Positive 4 now is your final answer for this example. So for example number 9, evaluate the function f of x is equal to absolute value of x minus 8, where the absolute value of x minus 8 means the absolute value of x minus 8 if x is equal to 3. So we just simply apply, or we just simply substitute the value of x, which is equal to positive 3, to the variable x in the given function. So your f of 3 now is equal to the absolute value of 3 minus 8. Since the absolute value of 8 is greater than to the absolute value of 3, uh, we follow the sign of the higher absolute value of a number, which is negative. That's why it's negative 5. So if we get the absolute value of your negative 5, we just simply arrive to a resulting value which is equal to positive 5. Therefore, your f of 3 is equal to positive 5. So this will be our final answer for this example number 9. So for example number 10, it's the same process. So we need to evaluate the function f of x is equal to x squared minus 2x plus 2 at f of 2x minus 3. So we just simply substitute this 2x minus 3 to your x variable. That's why it's 2x minus 3 square from this 1. So we copy your negative 2 here, then we substitute 2x minus 3 to your x in your given function. Then we copy your 2 here as your constant. So your f of 2x minus 3 now, so we can simplify this portion by simply applying the special product. So your special product, your first term for your special product is the square of this 2x. That will be equal to 4x squared. Now, your middle term here will be dependent. That will be the resulting value of the twice the product of your first and second term. So what will be the twice of the product of this first and second term? So 2x multiplied by 3, so that will be 6x multiplied by 2, because our pattern is twice the product of your first and second term, so that will be negative 6x multiplied by 2, it's negative 12x. So we just simply, our last term now is the square of your second term, which is negative 3. Negative 3 squared is positive 9. That's why it's positive 9 here. For the next term, we just simply distribute negative 2 to 2x, negative 2 to negative 3. So negative 2 multiplied by 2x, it's negative 4. Negative 2 multiplied by negative 3, it's positive 6. They are both negative numbers. So we copy your constant 2 here. Upon simplifying, so we copy the first three terms, then we copy your Second, three terms, which is negative 4 plus 6 plus 2. Now, we just simply rearrange your terms by variable and exponent. So, our leading term now is 4x squared minus 12x minus 4x plus 9 plus 6 plus 2. This will be your constant for this one. So, we just simply add this one. That will be equal to 17. So in this portion, we have the same variable and same exponent, so we can simplify this one. They are both negative terms, so negative 12x minus 4x is negative 16x. Then we copy or we bring down your 4x squared here. So our final answer now is 4x squared minus 16x plus 17. So that will be your final answer for example number 10. So for your activity, evaluate each function at the indicated values of the independent variable and simplify the result. So your f of x now, up to your f of x from 1 to 5 here. So we really need to get the value of this one. So we just simply substitute the given values of for your variable x. What we really need to do is to substitute these values to all the variable x in uh, your given function from f of x, g of x, h of x, f of x from 1 to 5. So thanks for watching. Like, comment, and subscribe.